7 years back in 2017, I was working on a project called BlueStacks TV and Relay Live. We were building a mobile app for the US and the Asia Pacific regions. We built the Android app first, and when writing the app logic and the data layer on iOS, I realized that we are basically writing the same logic, but just in a different language and using slightly different platform APIs. I reached out to the tech lead, and because I could see an opportunity to have a common language that can act as a wrapper over Java and Objective-C so that we don't write code twice. Well, back then we had React Native, but as it appeared, our team was not very comfortable with it. We did look at Cordova, but they were based on WebView-based solution, which was not very performant. We couldn't really achieve anything, and we still went the native way. Well, fast forward to 7 years, in 2024, the world has changed, and it looks like we finally have something worthwhile. While React Native and Flutter already do a decent job, Kotlin Multiplatform has an entirely unique spin at the problem, and that is exactly what we are going to talk about in this video. Okay, so the question we have for today is it really worth learning or even considering to explore what's happening in the world of Kotlin, and specifically Kotlin Multiplatform? We will see how it stands up against the competition, specifically Flutter and React Native. If you are new to this channel, I have created similar videos on Flutter and React Native. Please check those out. Link should be here and here. So in this video, we will also talk about the KMP internals and why you should really care about it, apart from the regular stuff that we have been doing for the last few videos. Okay, let's begin. Okay, before going to the KMP internals, let's understand why we need cross-platform in the first place. So you're supposed to build a very nice mobile app, and you have multiple SDKs offered by various platforms. And of course, instead of building like each one of those apps, what you would prefer is that there is this very nice cross-platform SDK which abstracts out everything. And at the core of it, every cross-platform has like three main components. So one is the UI toolkit, like painting the pixels on the screen. Then the second one is platform interaction, which is like disk IO, network IO, or sensor interaction, or things that are related. And the third one, or actually the primary one, is the language itself, like the coding language. But the real fun actually lies with like how each of these technologies approach the problem. Let's talk about Flutter first. So coding language used here is Dart. Dart compiles to native code, including the Dart runtime and the Flutter engine. Platform calls use NDK or JNI. With UI rendered via the Skia library on Android. On iOS, similar to Android, but it natively supports code execution without NDK. And platform interactions use the iOS SDK, and the UI is also painted using the Skia, but on an MTK view. Well, on the web, Dart is transpiled to JavaScript. Well, no runtime needed. Interactions occur through JavaScript APIs with UI rendering via the Canvas kit, which again includes Skia. Let's talk about React Native. So on Android and iOS, it takes a slightly different route. It uses TypeScript and JavaScript, which is directly added to the app binary without compilation. A JavaScript engine has to be included, which can really run this code. On the UI toolkit side, it has platform-specific code that communicates with the JavaScript code via the JS bridge. Now, the traditional JS bridge was really slow, but with the new JSI, the JavaScript interface, there's minimal overhead, allowing direct calls between JavaScript and Java using the JNI and latest stuff, which is available from the V8 engine. We'll go deeper into it in a separate video. So on the web, JavaScript runs almost as is, mapping to the DOM elements utilizing React.js under the hood. And finally, let's talk about Kotlin Multiplatform. So coding language is Kotlin, if it was not obvious. Kotlin is directly transpiled to Java bytecode on Android, native code on iOS using Kotlin Native, JS code on web using Kotlin JS. Platform interaction is done by calling platform APIs directly from within the Kotlin code, which is like crazy. There is literally zero boilerplate code that has to be written as opposed to React Native and Flutter, where the library author has to provide like platform channels or extra C++ code to achieve the similar stuff. UI toolkit over here is Compose Multiplatform, which does ship Skia library on iOS and web, but you can choose to opt out and still build the native UIs and then cross-communicate with Kotlin. Well, quick pause here. If you are a mobile developer and want to explore KMP and looking for just one video or just one page to begin with, well, this is what you should follow. The Getting Started guide from JetBrains is awesome. and you see how it gives you two options to go ahead with. This talk by JetBrains around building a KMP app in 40 minutes is probably the best resource I could find to write a Hello World app and really understand what's happening behind the scenes. Okay, let's talk about KMP developer experience now. I recently started with KMP, and the first page that they've built is really amazing. You start with this Kotlin Multiplatform wizard. You can add your project name, project ID, and you from here itself, this is a web page, you can select what platforms you want to cover, and the moment you hit download, the project will be downloaded and you will be able to import it into IntelliJ or Android Studio. The other cool thing is that you have this really nice template gallery where they already have templates of a few standard things that you'll anyway end up doing. Either you'll create a multi-platform library, or you will create a shared UI multi-platform app. You might create a native UI multi-platform app as well. Now, the project structure itself is really cool. So the build system is Gradle. So most of the Android developers will be familiar. You have around 4 modules by default, depending on the platforms that you've chosen. This Wasm.js main is for web, then iOS main for iOS, Android main for Android, and this is the common stuff. In the common module, you have this app.kotlin, which has the basic compose code and a normal data class. And so this is the interesting bit. Whenever you want to communicate with platform-specific components, what you do is you create an interface, then you create a method, you use this modifier called expect. Then in the platform-specific code, you implement that interface, and then you use the modifier actual. And when the code is running, it'll figure out the right platform and it'll get the right implementation by itself. And you realize that you are just writing Kotlin and nothing else. So this is really a nice, very nice utility that you have for this cross-platform interactions. Yeah, the other cool bit is that it is actually interoperable with Objective-C. So if you want to add an iOS dependency, so let's say there is an iOS library which is written in Objective-C, so you can use it with Cocoa pods, and when you're using it with Cocoa pods, you don't need to manage the pod file yourself. Pod file is managed by the build system, which is really nice. This is one of the problems I had with Flutter, where sometimes I have to change the pod file and it becomes tricky. And once you do the setup, you can directly import your Objective-C code into your Kotlin code, which is amazing. So what's really cool about this interoperability is what McDonald's did in their app. So what they did is they actually didn't want to convert their iOS and Android UI to how it's done in React Native. So what they did is they had a very complex business logic in their app. They wrote a KMP module which had, so this pink rectangle, this is basically a KMP. You can think of it like a KMP library, which has the domain logic, like fetching from the network, storing it in the DB and everything. And their Android and iOS apps actually use this common library. Now, this, my friends, is a major pro over all the other cross-platform options that we have, because all the libraries that are already written have to be adopted for cross-platform in other cases, or you have to use like a different language, which is a little weird. So a very, very nice example is that there is a library that only supports Android, but you want to use it. On Flutter, you will build like a platform channel for it. On React Native, you'll have to write a JSI module, that convert it into a JSI module and write some C++. But with KMP, you basically do the setup and everything is done for you. You just import the code and start calling out methods directly. I think that was enough of a dive. Let's talk about the job prospects now. If you see the top paying technologies from the Stack Overflow's developer survey, from 2019, we can see that for Kotlin, the median salary is like 57K. TypeScript is around 60K, and where is JavaScript? JavaScript is like 56K, still below Kotlin. In 2 years after, in 2021, we can see that the median salary for Kotlin has actually decreased by 2K. So even for TypeScript, there is like a little fall here. Not sure what happened in 2021. Anyway, so 2 years after, we can see some significant jump in all the median salaries. But one fun part is that Kotlin has overtaken TypeScript now, which is pretty interesting. Like Kotlin has taken TypeScript and JavaScript, but JavaScript was anyway behind Kotlin. So at least from here, it looks like that Kotlin developers are well paid. And now with that, let's come to the number of openings on LinkedIn. So if I just see the number of openings on a per cross-platform technology basis, then this is how the trend looks like. For US, Android is leading with around 30,000 jobs. On iOS, we have around 10,000. Then we have React Native, which is around 5.6K. Then KMP, like 3-digit 936. Then Flutter 834. For India, again, Android is leading with 15.8K jobs. Then we have React Native with 7.7K. Then we have iOS, which is 5.1K. Then Flutter is around 1.5K, and KMP is like 3-digit 343. Oh, wow. So it's very clear that KMP stands nowhere. So I actually searched Kotlin specific job openings as well, which are at least more than the Flutter openings, both in the US and India. If you're wondering that Kotlin is probably the last thing you should learn, then hold your horses. It should be pointed out that Kotlin is the official language for Android. So the 30,000 jobs that you see, to be generous, even if 40% are Kotlin out of them, we are looking at around 12,000 jobs, which is quite more than React Native and Flutter. I know I'm like mixing Kotlin and KMP, but they're indeed mixed. Okay, let's talk about the funding and the stakeholders. Let's spend some time on Kotlin language first. So Kotlin language is funded by like JetBrains and now Google too. It's more like a shared responsibility among the two. JetBrains is the primary owner and the developer of the language, but Google took it way further by shifting its Android ecosystem approach to Kotlin first in 2019. The primary libraries used for Android development like Jetpack and a lot of others are written by Google. Android Studio heavily integrates with Kotlin language, like features and tooling around it. Google also provides Android KDX that are basically Kotlin wrappers around the existing Android APIs and leverages Kotlin language in the best way possible. And these extensions are also part of Jetpack. And there are other set of stakeholders who have been using Kotlin for the native Android development. And the list is endless and huge because Kotlin was made official Android language around like 5-6 years back. If we talk about KMP though, KMP website has some really good success stories from various companies like Forbes, Cash App, Netflix, McDonald's, Philips, Autodesk, and a few others. From this list, it's very clear that as of today, there are only a handful of companies that are actively engaged with KMP. Okay, let's talk about popularity in developer ecosystem. On the popularity front, so we in the last few videos, we saw this really nice chart that shows like what kind of a bang all these technologies are making in the developer ecosystem. We can see that Flutter and React Native are leading in almost every front. KMP is a little far behind. Like if you see the Reddit followers, they are 83K, but the Stack Overflow questions are like a whopping just 1.7K, whereas for Flutter, it's like 178K. So this kind of goes on to show that KMP is relatively very new. On the flip side, Kotlin though is a language which is very mature, has been there for a while. And if you see the Android developer Twitter followers, they are like 2.2 million. And assuming like even like 50% of those developers are actively using Kotlin. So you will get very nice support from Kotlin. It is very popular. And with that, let's talk about Kotlin popularity actually. It has risen in the last few years, but the rise itself seems marginal. If we see the Stack Overflow developer survey from 2019, then Kotlin was at somewhere around 6.4%, JavaScript was 67.8%. 2 years after, Kotlin jumped to 8.32%, JavaScript is still on the top. Then 2 years after that, Kotlin had like just a very minor increase and it went to 9.06%. So another interesting bit in 2023 is that Dart has reached almost similar popularity level as Kotlin. Now, if you remember the data we saw earlier, with the number of open Android positions is way more than Flutter. So this closeness and popularity doesn't make a lot of sense. Well, the only inference I could make is that almost everyone is at least interested about learning Flutter and Dart just for the fun of it. Well, coming back to Kotlin, it does look like it's the popularity is not rising as sharply as it should have been after becoming the official Android language. But I really don't know what to make out of it. Okay, let's talk about packages and libraries. If we talk about packages and libraries, we discussed it before as well. While we don't have a lot of KMP libraries available, you can still use your favorite iOS or JavaScript library by having the Kotlin bindings. I did come across this very nice list of KMP libraries. The link should be down below. Give it a try. Okay, coming to the user experiences side of things. The first one, of course, is app size. Again, during my recent explorations, I came across this very nice GitHub repository called Flutter versus Native versus KMP. Says it out pretty loud and clear. The guy actually built the same app using multiple technologies and then compared the app sizes. On Android native, the app size is 1.4 MB. With KMP, it's still the same as expected. With Flutter, it's a 6x increase, which becomes 6.8 MB. On iOS side, the native is 1.7 MB, but with KMP on iOS, it's a whopping 24.8 MBs. which is crazy. It's like a 20x jump. It's mostly because of the shipping of the SWE library and the extra code. But I believe if you are using native iOS UI, then the number will be quite less. On the Flutter side, it's also a whopping 17.9 MB, which is crazy, but at least like less than KMP. So these numbers were taken on a minified release build, just FYI. On the performance side, the same guy actually captured startup time metrics as well. We can see that on Android, for native Android, the median was around 413 milliseconds. With KMP Android, it's a little higher, 425, but with Flutter Android, it's like way higher. I believe it has to do something with the initialization of the Flutter engine. On iOS, the native iOS takes around 1.4 seconds. KMP on iOS takes around 1.6, and Flutter also takes around the same time. This is crazy. I didn't know that iOS apps actually take a lot more to start up than the Android apps in general. It's like a 3x increase. All right, learning curve. Let's talk about KMP first. So if you don't have any experience with a composable UI framework, KMP is the easiest to embark on because you can still use the native UI and depend on the common Kotlin native module. If you talk about Kotlin language, so if you know Dart or TypeScript, the learning curve won't be that steep, because most of the features like nullability, extensions, lambdas, etc., you have those in the other languages as well. If you know Java, the learning curve will be more natural because Kotlin originally only compiled to the Java bytecode, and most of the articles in the books that have been written are written primarily targeting the Java developers. And quick note on developer tooling here. So Android tooling is amazing by definition, like in KMP. JetBrains went above and beyond by building everything in one IDE. You get cross-language refactoring, cross-language debugging, cross-language code navigation, and all of this is just insane. I mean, this stuff is not there in Flutter or React Native, and I don't think if it can even be built there. Well, okay. Oh, we are towards the end finally. So when should you use KMP? The first thing is when you need to have incremental platform independence. KMP is like ideal for gradually making parts of your code platform independent while preserving your UI and building a common data layer. The other point is when you have existing Kotlin Android apps. If your team consists of native Android developers familiar with Kotlin, transitioning to KMP will be straightforward with minimal code restructuring. Then the third point is if you have Java developers transitioning to Kotlin. If your team mainly consists of Java developers eager to switch to Kotlin, KMP offers a modern approach that facilitates the transition. The fourth one is when you have a business logic heavy app. Well, KMP is well suited for apps with complex business logic, allowing you to avoid redundant code and simplify maintenance. Fifth reason is if you are starting absolutely fresh and nothing in hand. Now this one might be controversial, but hear me out. You need two things. You need to be able to hire people who can work on this stuff, and you need to move fast. As we saw with the job openings, people for Flutter or React Native might be hard to find, but a person who knows Android Kotlin might be more readily available. So you need to hire Android Kotlin persons and ask them to just build an Android app using KMP way. 90% of their work will mostly remain the same, as if they were building for Android. But at the end of it, you will have an app available for web and iOS as well. Well, the one problem with this, however, is that there is not a lot of community and ecosystem support specifically for KMP. But on the Kotlin language side, you will be all set. And when you should not use it. So the first reason is when you have a team of web developers. So if your team is primarily composed of web developers who are comfortable with JavaScript or TypeScript, then React Native might be the way to go. The second reason could be if you have strong performance guarantees, if you need strong performance guarantees. So for graphics heavy apps requiring optimization, going native might be best to avoid performance issues or boilerplate code. However, KMP could still be viable if you build your own UI for iOS and web. The third reason would be compilation time. So KMP may introduce performance overhead during compilation, especially for large apps, which could significantly increase build times. Fourth one would be if you have a functioning iOS app built in Swift using numerous Swift libraries, you may face challenges with direct communications between Kotlin and pure Swift modules. So conclusion, well, I don't think if it's really that straightforward to conclude anything. I'm personally looking forward to where it goes. And whatever next app I'm gonna build, I'm gonna just go the KMP way. Well, it feels that it's doing the most right thing. Well, you hear that most right thing, because it's not that the other technologies are doing something wrong. They're also doing the right thing. It's just that this one feels like a little more natural to me, at least. And with that, we have reached towards the end of the video, and I'll create another one which will be hopefully last in the series, where I'll go a little deeper into the implementations of all these 3 technologies that we have. Been quite a journey, having a fun time researching all of this, and I'm sure you guys are having the fun time as well. Well, that's it. I hope I'll see you in the next one pretty soon. Bye.